welcome back. We're going to talk about the last section in Chapter 8 today, and that is parametric equations. So, a system of parametric equations is a pair of functions, x of t and y of t, that together represent some joined situation in which both x and y are functions of t. So both x and y depend on this variable t, and y also somehow depends on x. So let's talk about an object that is moving at constant speed. And this object moves at a steady rate along a straight path. From a point that has been assigned the coordinates -5, 3, to another point that has been assigned the coordinates 3, -1 in 4 seconds. And our task is to find parametric equations for the position of the object. So what that means is we're going to write x as a function of t, and we're going to write y as a function of t. Now, what we need to understand is that this guy is moving at a steady rate. So we know that when t equals 0, my x is -5. When t equals 4, my x is 3, because we started at an x of -5 and we're ending at an x of 3. Well, that means we moved 8 units in 4 seconds, so every second we're going to move 2. So we can go -2, So we move 2 meters per second horizontally. So -3, -1, 1, and sure enough, my 3 works out. Now I can do the same thing with y. And so if I build a table for y, when time is 0, y is 3. And when time is 4, y is -1. So vertically, I'm only moving 1 meter per second. So, and I'm decreasing. So my system, so I can write, so let's do our work here. This is a linear system. So x of t is going to be equal to my slope plus the y-intercept. And y of t is going to be equal to my slope plus the y-intercept. This then is the set of parametric equations that describes this object. And if I combine the two tables together, so I can express this in a more compact form by just having one column for each variable. So now I've got all my data together, and we can do things like graph x, we can graph y. More frequently, what we'll do when we do this work, is we will take a parametric set of equations and build that table and then graph x versus y, just like normal. The only difference being that we know that they're both x and y are related to t, right? And so we would graph this. Whoops, I need more. Well, let's see. Can I move this guy? Huh, look at that. Okay. So I needed 1, 2, 3, 4, -5. 1, 2, 3, 4. And my y's need to go from -1, 1, 2, 3. Okay. So when x is -5, y is 3. When x is -3, y is 2. When x is -1, y is 1. When x is 1, y is 0. And at x equals 3, y is -1. And we can see that's a straight line. Well, it would be a straight line if I graphed better. Let's try that again. Okay, that's better. Some of my points are off. Or my line is off. My line is off. It doesn't matter. You can see it's a straight line. Something's not okay. Okay. So if I graphed better, this would be a straight line. We could actually eliminate the parameter and write y as a function of x. And we would do that by solving the bottom equation for t. So if I know that y equals -t plus 3, that means that t is going to equal y minus 3. And so now I can go into x. Right? And now this is a function that I can solve. So I'll solve this for y. So I can get x equals 2y minus 6 minus 5, which means that x plus 11 equals 2y. So we would actually write that as y equals 1/2 x plus 11 halves. Oh, I screwed that up, people. All right, let's try that all again, because I messed this up here. Let's be more careful. This tells me that -t equals y minus 3, which means that t equals -y plus 3. That's better. So now substituting in into the x equation, that's going to give me 2 times -y plus 3 minus 5. So x equals -2y plus 6 minus 5, which means that x equals -2y plus 1. So that means that x minus 1, so -1/2 x plus 1/2 equals y. And this is what we see when we graph that, right? So what did I do? Well, I did a few things here. I took a description here, and I developed equations for x and y as a function of t. So this really is the set of parametric equations that describes the motion of this object. What I did then was I actually graphically eliminated the parameter and graphed x as a function of y. And then I algebraically eliminated the parameter. Actually, all of this work eliminates the parameter and determines y as a function of x. So we're going to do a few more of these, and I'm going to show you what we can do with parametric equations and graphically, and how they're helpful for describing different shapes. So we'll be back.